This is Lingareddy. Today we are going to learn about capacitor. Okay. So capacitor is a passive element which stores the energy in the form of electric field. So while inductor stores the energy in the form of magnetic field, capacitor stores the energy in the form of electric field. So capacitance, capacitor. So capacitance of a capacitor can be given as C is equal to epsilon A divided by D. So here epsilon is the permittivity of the dielectric material, A is the area of cross section of a plates which are separated by a distance D. Okay. Here there is a slight difference between the dielectric material and the insulator. So dielectric material is a insulator, is also an insulator, but it has dipoles when they are applied with the electric field, while the insulators only obstruct the flow of current through them. Okay. So the capacitance C is equal to, here it is. So here epsilon is the permittivity and it is given by epsilon is equal to epsilon of epsilon into epsilon r into epsilon naught. So epsilon r is the relative permittivity of that material. Okay, here epsilon naught is the permittivity of a free space. Next, so when the two plates are given, this is the formula. When the number of plates are connected in this fashion, see here, this is for two plates in this fashion. When the number of plates are connected in this fashion, now what is the equivalent capacitance? So this is the practical situation. We will design the capacitors one of this fashion. There are so many techniques to design capacitors. So one of them is this. So here equivalent capacitance C equivalent is equal to sigma into A divided by D into N minus 1. Here N is the number of plates which are connected in this fashion. So here the number of plates is 8. So sigma into A divided by D into 7 will be the answer. This can be derived or said that these plates are connected in parallel. Actually, when the capacitors are connected in series, we will get C equivalent is equal to C1 into C2 divided by C1 plus C2. Is it? So here it can be written in the form of 1 by C equivalent is equal to 1 by C1 plus 1 by C2. This is exactly opposite relation to the resistor or inductor. Actually, when the resistors are connected in series, C1 and C2, and the resistors are connected in series, R1 and R2. So R equivalent is equal to R1 plus R2. Is it? So here the capacitors connected in series, but the equivalent capacitance is in this form. So that's why there is an inverse relation to the capacitor and the resistor. Okay. So how can we say these in this if the capacitor is designed in this fashion, the equivalent capacitance is this. So if the capacitors are connected in parallel, this is the true. So can we say, take this one of the part of this connected connected capacitor. Okay, here is C1, here is C2. See here, the current is division takes place, I1 and I2. So here current is collected and here is I. So there is a current division and current collection is there. So this is called parallel connection. Only in parallel connected elements only the current division will take place. That's why this entire passion is connected in parallel. Okay. Now, if there is any of them, so here we have taken that the area availability for each plate is same and distance of separation between each plate is same, and epsilon, that is material, dielectric material used between plates is same. In any case, there may be a different dielectric materials present. So in that situation, we have to take C equivalent is equal to C1 plus C2 plus C3 and so on. So here C1 is equal to, okay, take new phrase, C equivalent is equal to C1 plus C2 plus C3, is it? So here C1 is equal to, C equivalent is equal to C1 plus C2 plus C3 plus and so on Cn. C1 is equal to epsilon 1 into A divided by D plus epsilon 2 into A divided by D. Here we assumed that only dielectric material is changed. The area and the distance of separation is the same and so on. Epsilon n A divided by D. So this is, in any case, area, D, all changes, we can substitute those of them and we can get C equivalent. Okay. Now, the capacitors has the structure in this fashion. Then what is the equivalent capacitor? Yes, this is one of the fashion regularly used. So until this is a epsilon 1, until this is epsilon 2, this is the distance D, and here is C1 and here is C2. So by seeing them, they are connected in series fashion, is it? Is it C1, C2? So C equivalent is equal to C1 into C2 divided by C1 plus C2, is it? So what is? Now, what is C1? C1 is equal to epsilon 1 into A divided by D by 2 we have taken, because epsilon 1 occupies the distance up to D by 2, we have taken off of. So that is equal to 2 into epsilon 1 into A divided by D. Similarly, C2 is equal to 2 into epsilon 2 divided into A divided by D. So substitute these values into C equivalent, we can get the C equivalent. So capacitor can also be used in AC circuits as an integrator and differentiator depending upon the output voltage or current or connected fashion. Okay. See, in a capacitor, current leads the voltage by 90 degrees. Is it? So in a ideal capacitor, I leads V by 90 degrees. So this is a phasor diagram, I V. 90 degrees. So for a practical capacitor, it is not possible to get 90 degrees. There is a leakage will present. That's why there is a slight difference of angle will come. I dash. This is a theta which is less than 90 degrees. So for a practical conditions it is. If we take I is equal to V is equal to Vm sin omega t, will get I is equal to C into dV by dt, that is equal to Im cos omega t. See here, there is a 90 degrees relation, 90 degrees deviation between the input voltage and the output current. Okay, or in input voltage and output current, there is always 90 degrees deviation. So here cos function is leading than sine function, so it is a 90 degrees. I leads 90 degrees the voltage. Okay, next, for a capacitor, how to find the charge stored in the capacitor? So it's simple. So we can derive this charge, the amount of charge accumulated in the capacitor can be found by using current formula. Is it C? So what is I is equal to C into dV by dt. Here one more statement is there. So voltage across the capacitor can't change instantaneously. So to change such that means to change the voltage across the capacitor, we have to give infinite amount of current. Is it? So at dt means zero amount of time means instantly means zero amount of means time. So dt is equal to 0. So that is equal to I is equal to infinity will come. So infinite amount of current if you supply to the capacitor, it will charge voltage instantly. Practically it is not possible, so it is one of the statement to remember about capacitor. So I is equal to C into dV by dt. I is equal to dq by dt, we know that dq by dt, is it? So charge crossed in a conductor in a crossed a area in a time dt or unit time. Okay, so that's why. So dq by dt. So dq by dt is equal to dv by dt. See here this is okay. So uniformity is present. If we assume, then q is equal to C into V. This is a formula we have got. Okay, next, some more problems are present here. See circuit 1. Figure 1. Try yourself and say the answer. Okay, next, take here. We have a circuit of this fashion. See here, this is the circuit we have seen in the screen. By seeing the capacitors here, C1, C2, C3 all are connected in parallel. Is it? See once. So this is the point, this is the point, this is the point, this is the point. If we take A here, so short circuited A also. B here, circuited B. So all are connected. C1 connected here, C3 also connected here, C secondary end, C1 connected B, B, B. So it can directly say C1 by C equivalent is equal to, is it 1 by C1 plus 1 by C2 plus 1 by C3. This is the way we can solve this problem. See, next question. In next question, we have to find the charge on each capacitor. Is it? So this is one lengthy problem. See how we will solve this. Okay, this is the circuit we have seen on the screen. Okay, see here, whatever we got this circuit, we have to simplify and we have to find the voltage across each branch, and then we can find the charge by using charge Q is equal to C into V. We know the capacitance of each capacitor, so we have to find only the voltage across each branch. Since, see here, what is the voltage of these two capacitors are connected in parallel, so C equivalent is equal to 1 microfarad here also C equivalent is equal to 1 microfarad. And now see, these two branches are connected in series like this fashion. 100 volts, 1 microfarad here, 1 microfarad here. So here is 1 microfarad. After all, we'll see that the voltage is divided equally. So here is 50 volts you will get, here is 50 volts you will get. Is it? Since these two are connected in parallel, come to real, so original circuit, so these two are connected in parallel means, so there is a equal amount of voltage will be appear, that is 50 volts. 50 volts. Here also 50 volts will get. Since we know voltage and capacitance, we will find the charge on each capacitor. That is, charge on C1 is equal to 50 into Q1 is equal to 50 into C1. So 50 into 0.8 microfarad. 0.8 microfarad. That is equal to 50 into 0.8 into 10 power of minus 6. That is equal to 40 microcoulomb. Q2 is equal to 50 into 0.2 into 10 power of minus 6, that is equal to 10 microcoulomb. Similarly, Q3 is equal to 35 microcoulomb. Q4 is equal to 15 microcoulomb will be appear. Next, third question. So third question is a see third question. Do yourself. Next, see, the question is, the capacitor has a capacitance C is equal to 200 microfarad. Is it? Next, so the energy charged in the capacitor E is equal to 50 millijoules. Now we have to find the voltage, charge and time to get this charge T. He has given also the uniform current I is equal to 0.5 amps. Okay. Now we know that energy stored in the capacitor E is equal to 1 by 2 CV square. Is it? So how we have get this formula? This formula can be derived by using P is equal to V into I. That is equal to V into C into dV by dt. Is it? That is equal to C into V into dV by dt. P is equal to. So energy E is equal to integration of P into dt. Okay. So 1 by T average energy. So not. Okay. Next. So here C into V into integration of V dV by dt into dt. Okay. C into integration of V dV, that is equal to 1 by 2 C V square will come. This is the derivation for this energy. Okay, now from this V is equal to root of 2 into E divided by C. Okay. Next, we know that energy E V is equal to root of 2 into 50 into 10 power of minus, is it 3 divided by C is 200 microfarad. Okay, that is equal to root of it is 2 this cancels, 5 into 10 power of minus 3 divided by 10 into 10 power of minus 6. Is it? Root of 0.5 into 10 power of 3 will come. This is. Next, what is Q? Q is equal to C into V. We know 200 microfarad C into 10 power of minus 6 into V, root of 0.5 into 10 power of 3. Next, so time. So we have one relation that, so since current is same, that is I is equal to C into V divided by T. Is it? No, it is not. So T is equal to, so yeah, this formula we can use. I is equal to dq by dt. So uniform current means Q divided by T. So Q is equal to, so here, sorry, we'll use this. So time T is equal to I is equal to Q by T. T is equal to Q by I. What is Q? Q we have got, that is 200 into 10 power of minus 6 into root of 0.5 into 10 power of 3 divided by what is I? 0.5. So that is equal to 4 into 100 into 10 power of minus 6 into root of 0.5 into 10 power of 3. That is equal to 4 into 10 power of minus 4 into root of 0.5 into 10 power of 3. This is the solution for time. Okay. Next. We have got one waveform. See on the screen. So what is the current in the capacitor? This is the waveform we have got. Next, see. So we know that I is equal to C into dV by dt. Is it? Since capacitance is given 2 microfarad, or you can take 1 microfarad, any one of them, only magnitude will changes. Okay, so I am taking C is equal to 1 microfarad, okay, or 2 microfarad, you can take any one. Next, this is, so since differentiation taken whenever a polynomial or a straight line, if a straight line is differentiated with time, then we will get only slope. If a second order polynomial is differentiated, we will get tangent. So what is the slope of this, and multiply with C, you will get the current voltage, current changing in between the 0 and 1. So 0 and 1, what is voltage? M. So this is 1, so it is directly taken, 10 will come. So after the 1 and 2, there is no change of current means, so there is no change of voltage means, so there is no change of current. Whenever, next, see here, the 2 to 4, there is a large change in voltage means there will be large change in current also. So what is the slope here means? So we can find the slope in this formula, on this form, that is, so it is point, this point is 2 comma 10, and this point is 4 comma minus 10. Is it? So here we can find M is equal to y2 minus y1 divided by x2 minus x1. Use this formula and we will get M is equal to minus 20 divided by 2. Is it? So minus 10. This is minus 10. Next, here is, there is no change in voltage up to 5. So there is no change in current also. So there is a 0 current. Next, there is a change in voltage of slope, same as this. So increment. This is the form of current. See here, we have taken T in seconds and capacitance also in microfarad. So there is a slight changes. So here 10 millivolts, microvolts will come. Here also minus 10 microvolts will come. Depending upon the capacitor chosen and T taken, actually T will be in milliseconds. So capacitors will be as usual in microfarad. So here we have taken in seconds. So if you take milliseconds, here voltage will be 10 millivolts. Here also minus 10 millivolts will come. Okay, take attention here. There is some mistakes will taken place. Okay, this is about capacitors. Next we will do some problem session on the R, L and C networks. Okay.